Hello and welcome to solve for the solution to my cube puzzle. So, how many ways can we paint the sides, the faces of a cube with three colors to get different cubes? I mean, how many different cubes can we get? Whatever. You got a problem because you're here for the solution, right? So to solve this puzzle, we're going to use a lemma from the group theory, which is called the lemma that is not Burnside's. It's also called Burnside's lemma. It has actually many different names. Burnside's didn't prove this lemma, he didn't discover it, but mostly his name is attached to it. So if you want to see the historical reason for that, well, just check it out on Wikipedia even, and you're gonna see it. So what does this lemma say? It's a little bit intricate when you read it, especially if you're not familiar with group theory. But for our cube, it's a little bit easier to explain. So we have a cube, and for a cube we have transformations. A transformation is a movement that will change my cube into another cube, like this very rotation, 90 degrees. You have also other transformation like 180 degrees, etc. So you consider this transformation, and for each transformation you are going to calculate the number of configurations that are not changed with our transformation. For instance, if my cube is completely red, I can do this, it's gonna look exactly the same. So this is one configuration where the transformation doesn't look like it's doing anything. And for each of the transformation, we're gonna count that, and we're going to divide all those numbers we're gonna count by the number of transformations. And the result, which is surprisingly an integer, will be the number of this distinct cube we can paint with our colors. Here's the first transformation. We take our cube and we do nothing. That's called the identity. And the identity will change my cube into the same cube. How many ways can I paint my cube that it doesn't look changed with the identity? Well, all the ways. So we have three possibilities, three colors here, multiplied by three colors here, three different colors, way to color here, three different ways to color here, and three different ways to color here. So this will make 3 multiplied by 3 multiplied by 3 to the power of 6. That's one transformation, and 3 to the power of 6 possibilities. Now let's see, another transformation we can have with this cube is to take a cube and take this face, for instance, and turn 90 degrees clockwise. That's another transformation. So if I do this transformation, how many ways can I paint my cube that nobody will see that I would do this? Well, if I have a color here, another color there, and I rotate, those colors are not gonna look like they moved. So I can put any color on the face or on the front or the back. But here on this side, I have to use only one color for all 4 of those squares. So, which means that I can paint 3 different colors here, doesn't matter, 3 different colors here, and 3 different colors, but the same for the 3. So, it's for the 4 faces. So that means that we have 3 multiplied by 3 multiplied by 3 for this transformation. And you know what? This kind of transformation, take a face and rotate 90 degrees. I can do that 6 different ways. With this face, that face, that face, that face, that face, and I missed one, whatever. So 6 different ways, because 6 different faces I can rotate 90 degrees considering that face. So that makes 6 times 3 to the power of 3. So far we have one identity, and those 6 make 7 transformations, and a lot of configuration that don't look like moving. Next transformations, well, take again a face and rotate it 180 degrees. How can I paint my cube so as it doesn't look changed? Well, here on the front or the back, again, I can do whatever I want, so it's 3 possibilities here and 3 possibilities there. On the top and the bottom are going to be, the top and the bottom being exchanged, they have to be the same color. So that makes, again, 3 possibilities for those 2 faces together. And of course, those 2 on the sides are going to be also exchanged, so they have to be the same color, and again 3 possibilities, so it makes 3 by 3 by 3 and by 3, so 3 to the power of 4. How many of these transformations do I have? Well, I have this one, I have this one, and I have that one. That makes 3 of them. Are we done with all those transformations? Well, if you play the Rubik's Cube, maybe you might think that that's all, but no. There are more transformations that can change a cube to another one. And here is another one. You take the axis that goes from this edge right here to that edge here, like this. And you can rotate your cube 180 degrees. I try to do it better. And your cube doesn't look like change. And that's it. So that makes a transformation, new kind of transformation. What possibilities do we have for this transformation to be invisible? Well, these 2 colors are going to be switched. These 2 colors back and front are going to be switched like this, and these 2 colors have to be switched. So those 2 have to be the same color, those 2 have to be the same color, and those 2 have to be the same colors. Make 3 multiplied by 3 multiplied by 3. How many of those this kind of transformations do I have? Well, I have one here in the front, going to the bottom back, one here, it makes 4, and we're not done. One here, that makes, well, 6. Are we done with those transformations? Well, not at all. We have more, but we're almost done. We have one more family of transformations. Take your cube and take one corner here and one corner here, and you're going to rotate your cube 120 degrees, and it's going to change it. That's this kind of rotation, like this. Wait, I'll do it properly, like this. So you can rotate the left and right, but we're gonna see that if you rotate left, it's because you can consider the opposite vertex and turn right, so it doesn't really matter. So we have 120 degree rotation, let's say clockwise. How do we make this rotation invisible? Well, we have to color all those 3 faces with the same color, and the same for the back. They don't have to be the same color front and back, but those 3 and those 3 have to be the same color. So that makes that we have 3 choices here and 3 choices here, and that makes 9 choices. How many of these transformations do we have? Well, it's very easy. We have 1 per vertex actually, because this one from here 120 degrees is different from that one, because it rotates the other way if you prefer. So that makes 1, 2, 3, 4, 5, 6, 7, 8 transformations, and that's it. So now we have all our transformations, and we have all the combinations that don't look change with those transformations. We divide the second by the first, and we get 57. And yes, 57 is the answer to the puzzle. We can, 3 colors, we can make 57 different combinations or different cubes. I hope you enjoyed this puzzle, and see you next time for next puzzle. Bye bye.